In today's video, we'll be going through arithmetic and geometric sequences. Well, the base equation for a recursive arithmetic sequence is a of n equals a times n minus 1 times plus d, and the explicit form for an arithmetic sequence is a of n equals a plus n minus 1 times d, and d just represents your common difference. For a geometric sequence, a of n equals a1 times r to the power of n minus 1. Well, we have some practice problems here which say that we must find the missing information and write them in explicit form. Well, we can see that this first problem is just an arithmetic sequence. Given a subscript 4 equals 6 and a subscript 11 equals 54, determine d, a, and a of n, or the nth term, which whenever you see a of n, just means you're looking for the equation. Now let's go ahead and do this problem. Well, let's go ahead and choose a different color. And a of 4 equals 6 and a of 11 equals 54. So if we need to solve for d, let's see what we can do. Now, when you want to solve for d, what you want to do is you're going to do your terms, which are going to be 54 and 6. So we have 54. You're going to subtract 54 minus 6 over your subscript and subscripts. We did 11 minus 4. So it's going to be your term, your output value, over your terms. Well, now we have 54 minus 6. 54 minus 6 is just 48, and 11 minus 4 is just 7. So we have 48 over 7. So we're just going to leave that in fraction form for right now. And this is just representing our d value equals d. Now, what we need to do is go ahead and solve for a1. Well, now that we know our d, we can actually just use our explicit equation in order to help find our a1 value. Well, this term, the subscripts, are known as your n values, regardless of geometric or your arithmetic sequence. So we're going to have our equation, and our base equation was n equals a1 plus n minus 1 times d. So now let's go ahead and substitute our values in. Well, what we can do in this type of scenario is we can substitute one of our given values because we already know the n value and we know what a of n equals. So now using our base equation, we're going to solve for a1. Well, we know our a of n is just going to be this value right here, where a of 4, so a of n is our 4, equals 6. So we're going to substitute 6 equals, we're solving for a1 algebraically later, plus n minus 1. We said n is going to be our subscript, which is 4. 4 minus 1 times our d value, which we found to be 48 over 7. Now we can simplify our parentheses down to 3. So we have 6 equals a1 plus 3 times 48 over 7. Well, 48 times 3 is just 144 over 7, because we have the 7 in our denominator. And we have plus a1. So let's go ahead and do that. We have plus a1, and this all equals 6. So now what we can do is we can isolate a1 on both sides. So we can subtract 144 over 7 from both sides. So now that we've subtracted 144 over 7, we're going to be left with 6 minus 144 over 7 equals a1. And 6 minus 144 over 7 is negative 102 over 7. And so this is equal to our a1 value. So now we have solved our a1. Now it also needs our a of n value, which is just, as we said before, just going to be our equation. Well, for our equation, what we're going to do is we're going to just substitute our values into this equation. But we're not going to have any type of a of n. We're just going to have a of n equals our a1 value, which we found to be negative 102 over 7. So we have negative 102 over 7, right? And then we have plus n minus 1. So we're going to have n minus 1 because we just want this to be a base equation, which you can use down the road for any type of n value. So we have plus n minus 1, and then we just multiply by our d value, which is 48 over 7. And that's going to be our a of n. So now we found our a of n value, we found our d value, and our a1 value. So we have finished this problem. Now let's go ahead and start our geometric sequences. Well, for geometric sequences, it says that given a1 equals 5 and a of 7 equals 233,280, determine r and a of n. Again, it's going to be the same concept here with a of n. It's just going to be another equation where you can substitute any type of n value and find your overall value. So we now have a new term, which is r. And r is actually just your common difference. Well, it's a little different than your arithmetic because it's going to be more of a common ratio where you're going to be multiplying. Now, if you remember, our geometric equation was a of n equals a1 times r to the power of n minus 1. So now what we need to do is use that equation. So we have a of n equals a1 times r to the power of n minus 1. Well, as of right now, we know our a1 value, so we can substitute that in. So we have 5, a of n equals 5 times r to the power of n minus 1. So now what we're going to do is we're going to do something similar to what we did in our last problem. We're going to substitute one of our given values in. So we're going to use a of 7. So we're going to have 233,280 equals 5 times, we're going to solve for r now, r to the power of n minus 1. Well, we use this number, and the n value was 7. So we're going to use 7 as our n. So we're going to have 7 minus 1 as our exponent. This just simplifies down to 233,280 equals 5 to the power 5 times r to the power of 6. Divide both sides by r. So 233,280 divided by 5 is 46656 equals r to the power of 6. So we take the sixth root on both sides. So we have 6 radical 46656 equals r. And if we do solve for r, we get r equals 6. So now that we've solved for our r value, we're done with one part. So now we have to solve for our a of n equation, and we're going to just use our equation, which we used right here, which is the base equation for a geometric sequence. Well, we said it's a of n equals a1 times r to the power of n minus 1. So we're just going to substitute in our a1 value and our r value, and we're going to be done. Well, we have a of n equals our a1 value, which is given, which is 5, and then times our r value, which we just found to be 6 to the power of n minus 1, and that is our answer. So our answers are 6, and a of n equals 5 times 6 to the power of n minus 1. Lastly, we have question number 3, which says a of 1 equals 4, r equals 5, and a of question mark equals 488281250. That's a big number. Solve for the question mark. So we're solving for this n value right here, which we don't know. Well, we're given our a1 value. And if we're given our a1 value, we can go ahead and use our equation. If you aren't given your a1 value, you just do simple algebra and substitute different values. They would have given you several equations. Well, now we're going to go ahead and use our equation, which, as you remember, is a of n equals a1 times r to the power of n minus 1. Well, right now, the only type of a of n we know is this a of question mark. So we can go ahead and substitute that in. So we can have 488281250 equals our a1 value, which is given as 4, equals 4 times r, which is 5, to the power of question mark, because we don't know our n value right now, minus 1. Well, now what we can do is divide both sides by 4. So if we divide our really big number by 4, we get another big number, which is 12207033125 equals, and we just still have our 5 to the power of question mark minus 1. 5 to the power of question mark minus 1. Well, now we can see that we have a 5 as our base, and it's going to the power of question mark minus 1. Well, we can't take any type of root at this point because we don't know our actual exponent. But what we can do is take the log. So we can take log base 5 of this number, which is 12207033125 equals, so this log is getting rid of this 5, question mark minus 1. So if we do take log base 5 of 12207033125, we should get a value of 13. And that should equal question mark minus 1. If we add 1 to both sides, we get 14 equals our question mark value. And then this problem is done. And now in our final problem, it says a of 3 equals 24, a of 8 equals 37.5, and we need to determine the r value, the a1 value, and the an value. Well, this problem is actually one of our geometric sequences, so we can go ahead and follow the same steps we did from our last question. And if you remember, our geometric sequence equation is a subscript n equals a subscript 1, or a1, times r to the power of n minus 1. Well, we actually know 2 of our values, so we actually don't know our a1 value. What we're going to do is we're going to do something a little different and out of the ordinary in order to solve this problem, as we aren't actually given the a1 value. And what we're going to do, instead of a of 1, we're going to be substituting in our a of 3 value. And for our a of n, we're going to be substituting in our 37.5 or our a of 8 value. So let's go ahead and do that. So we have a of 8. So we have 37.5. And we're going to set that equal to our a of 3 value, which is 24, times our, we need to find out, we don't know it yet, times n, and n is going to be 8 since that's what we had here. 8 minus 1. But it's not going to be 1 because instead of having a 1 here, we're actually having a 3 because this was our a of 3 value. So that's how we're going to go ahead and go about solving this. So we're going to divide both sides by 24. So 37.5 over 24 equals r to the power 5 because 8 minus 3 is 5. R to the power 5. Now we're going to take the fifth root on both sides. So we have the fifth root of 37.5 over 24. And this equals our r value. So now that we know our r value, we're going to actually just substitute this guy back into our regular equation and then solve for a1. So we have our equation, which is a subscript n equals a1 times r to the power of n minus 1. So we know a subscript n, we're just going to use the 24. So we have 24, that's our a of 3. 24 equals our a1, which we don't know we're going to solve for now, times our r value, which we just found here, which is 5 square roots of 37.5 over 24 to the power of 3 minus 1. And now what we're going to do is we're just going to isolate a1. And we should get that a1 equals 20.0763. So now we've solved for a1 and r. And now we just need to solve for our an equation. And for our an equation, what we're going to do is we're just going to substitute these values in to our main base equation for a geometric sequence. So it's just going to look something like a subscript n equals 20.0763, since that's our a1 value, times our r value, which is 5 radical 37.5 over 24 to the power of n minus 1. And that is done. I hope this video helped. If you believe it did, please consider like and subscribe. It would greatly help our channel. We have grown over 100 subscribers, and I really do appreciate all your support. Remember, we do have an Instagram if you want future video updates or you want to DM for video requests. Remember to subscribe, like, and hit the bell icon for future video updates. Thank you.